So tomorrow your quiz, I just looked at it, is 5 points. It'll just go into Skyward out of 5 points. There's no retakes or anything on it. It's just the one learning objective. The stuff that we learned yesterday, so common ion, finding KSP, and then finding X. And it's like a 1, 2, and then an ABC or something like that. So you'll take that tomorrow. I gave you a worksheet yesterday. That's really good practice. It repeats itself. It's kind of the same thing over and over again. So kind of after you get the hang of it, I don't think it's necessary to keep doing more of them unless you want to. We will not see this on a test until a CUME test at the end of this unit into the next unit. So it won't be like assessed officially for a long time. And okay, today we are going to start acids and bases. So go ahead and get out those notes. I'm going to use colors, so come grab colors if you want those as well. Oh, why are you spinning? Oh my God. I'm going to take a picture of that quick with the phone or something. I will text it to you. Come on. Why can't we just learn? Yeah, the hickey boy? Yeah. Oh no! Oh my God. Like, why did he fall? Like, on purpose? Really? Ow! He's such a spaz, like, all the time. I used to, like, help him organize his crap, and I gave up. I'm like, this is not worth my time. We need our gold packets. So you can get your gold packet out while we're waiting. What'd you say? No, because they mixed them all in the bag because they figured out it made carbon dioxide, so they wanted to explode their bag, and I didn't stop them, so they wasted it all. So it's got to be somewhere. I'll go on a hunt for it. I bet Kurth has it, though. Or Bergauer has it. Yay! Oh my God, you're recording that whole time. That's going to be annoying for whoever has to watch it. Okay. I don't think you guys got to acids and bases in honors chem, did you? Maybe like a teensy bit at the end, a little bit. So most of this is going to be brand new for us. Some of it might be familiar. Acids have 2 different definitions, and you're not going to have to be like regurgitate. The Arrhenius definition is, but in general, it has 2 definitions. The Arrhenius definition, it produces H plus ions in an aqueous solution. Okay, so here's the thing. It produces an H plus ion that instantaneous turns into an H3O plus, okay? Because if I have a bucket of water, and if I throw a single teeny tiny H in there, the water is immediately going to soak it up and turn it into H3O plus, okay? Like no matter what, like they love each other more than anything. Nothing is ever going to be separated like this. So when we do our math, we are always going to do it for H3O plus because it's the same thing as the H's. This doesn't exist. It's always going to turn into that. okay? So it's going to produce an H plus in an aqueous solution, water. The other definition is it is a proton donor. So atoms have protons, neutrons, and electrons, okay? Hydrogen is number 1, so that means it has 1 proton. It actually doesn't even have a neutron, it's super teeny, but it does have that 1 electron. But an H plus means it lost its electron. It has 0 electrons. So an H plus is literally, actually, just a proton. So H plus equals H3O plus equals proton. All synonyms, all used all over the place, but they all mean the same thing, okay? Acids usually, like 95% of the time, start with a hydrogen. They're way easier to pick out because they have that hydrogen at the beginning. Not always. We're going to look at appendix dinosaur in a little bit, and we'll look for ones that don't start with a hydrogen, but they almost always start with a hydrogen. A is not an element. I mean it to be like acid, any kind of anion, okay? What's going to happen, oop, this is AQ. Water is always going to be liquid unless it like isn't below freezing, then it would be a solid, but that's not going to happen. You can just always, H2O is always going to be liquid. So if I put an acid in a bucket of water, what's going to happen is they're going to collide with each other because why not, right? They collide, they have the right orientation, they have enough energy to overcome activation energy. What did I erase? Are we freezing again? What's going to happen is this hydrogen is going to be donated. It's going to give up its hydrogen to the water, okay? So if HA loses its hydrogen, what's left is A minus. Hydrogen is positive, so I'm going from neutral, -1, leaves me with -1. The H2O goes to H3O, and it gains a charge because it gained a +1. By definition, this is going to be the acid. It's the one that loses the hydrogen. Okay? When the music starts, can you please just talk to your bad buddy about ABC? I know you just wrote it, and it could be really simple. It's about retaining it. Remember, I looked at a lot of your goals was to like, I need to retain better. That means you actually have to like repeat it over and over again. You're just repeating what we did on purpose. Ready, go. Appendix dinosaur point 1 are all of the weak acids. There are 7 strong acids that you're just going to have to memorize. We've talked about them before. I'll be back in a couple days. But these are all of the weak acids. So if you look down the formula column, a lot of them do start with the hydrogen. So they're kind of easier to pick out. But look at the very first one, acetic acid. It does not start with a hydrogen, but it is still an acid. Those COOs, the COOHs, those are called ketones. They're double bonded oxygens. We saw them a little bit in the structures. But COOs are acids. Instead of the hydrogen being at the beginning, it's just at the end. So if you see a COO isn't weak acid. It's an acid. It just doesn't start with it. It ends with it. The hydrogen's on the butt, not the head. Okay, so if you keep looking down, like scanning down, benzoic acid is a COO. Butanoic acid is a COO. All right, keep looking. So it either starts with a hydrogen or it has a COO. If you flip the page to dinosaur point 2, there's a teeny table at the top. Those are the weak bases. Maybe you want to label it in there. Those are weak bases. Strong bases are easy to pick out because they're the hydroxide groups. Weak bases are so hard to pick out. if you look at those, some of them start with a hydrogen. So you might think it's an acid. But look, they all have an NH group. They're like NH, NH2, NH3. Maybe even with your pencil, circle those NH groups. That's going to help you remember. The NHs are going to be our weak bases. Strong bases are hydroxide group, weak bases are NHs. Weak acids are COOs, or they start with hydrogen. Honestly, guys, that's like a huge part of the battle, is being able to look at it and be like, okay, I know it's a weak acid. Now I know what to do. Okay? So when the music starts, can you just remind each other, how do I tell if it's a weak acid or how do I tell if it's a weak base? Ready, go. Vocab word, amphoteric. I know we just talked about how to tell when they're an acid or when they're a base, but most things can actually be both. Amphoteric means it's an acid and a base. A really good example of it is water. Water can be both an acid and water can be both a base, because all an acid is something that gives up a hydrogen. So water can give up a hydrogen. It'll give it up, and its leftovers are just hydroxide. Water can also be a base. A base gains a hydrogen. It can do that too. It just turns into H3O+. So it can do both. It just depends what it's reacting with. And that's called amphoteric. A lot of things are amphoteric. Auto-ionization, auto means automatically, ionization means ions, means that water, which is going to be liquid, can react with water. Because why not? If there's a gazillion of them in the same container, what would stop them from colliding in the right orientation with enough energy to overcome activation energy? Nothing. It's going to happen. So in this case, one of them is going to be the loser and one of them is going to be the gainer. The loser is going to be our acid. That's what an acid is. The gainer is going to be our base. But we just learned it can do both. So if we pretend the left one loses, it goes from H2O to H1O, which is hydroxide. And the gainer is going to go from H2O to H3O, gains a charge +1. Third new word, conjugate. If I have a base, not boron, this is just any base. React it with water, this is a Q, this is liquid. By definition, the base is a gainer. Right, it's going to gain that hydrogen. So it's going to go from base to H base +1, because hydrogen's +1, so it goes up 1. H2O goes down to H1O. We call that hydroxide because it's 1H1O. This is the base because it's the gainer. This time water is the acid. It can be either, but it's the acid because it's the loser. The partners, the leftovers, are the conjugates. So the base turns into the conjugate acid. The base turns into the conjugate acid, and the acid turns into the conjugate base. I want you to talk about it because I want to hear you say the word conjugate, and you're just retaining it, so you're repeating it on purpose. Say it and then hear it, so let everybody say it. Ready, go. Okay, let's do acids. Hydrogen, acid. They usually start with the hydrogen, but they could be a COO as well. That means they have their hydrogen at the end. Those are AQ plus water is going to be our liquid. By definition, the acid is the loser, the base is the gainer. So HA minus and H is an A minus. And H2O goes from H2O to H3O. The loser is the acid, the gainer is the base. The acid turns into the conjugate base. The base turns into the conjugate acid. So they're flip-flopping, right? The acid turns into the base, and this is why. For the reverse reaction, this is the acid. This is the base. He's the loser, he's the gainer. So the conjugates are for the reverse reaction. So if you have trouble remembering to flip-flop them, the conjugates are for the reverse reaction. Which one is the acid in the reverse? Which one is the base in the reverse? Okay, when you're done, put your pencil down and put up your cheerleading hands. I don't mean to be offensive to cheerleaders. I don't know if they actually do this. It's just what I think they should do. So one hand up and one hand down. These always have to be opposites. So the stronger the acid, the weaker the conjugate base. But then it's like on a perfect scale. So like even Steven, do it. Even Steven switching, middle. Even Steven switching. The weaker the acid, the stronger the conjugate base. When you multiply them, they have to equal a constant. So even Steven switching. The stronger, the weaker, the stronger always. Okay? So they're called cheerleading hands for no reason. Let's practice writing them. Turn your page. Oh my God. Are we here? Okay, so let's stop doing A's and let's start doing real things, okay? This number one is, these are all going to be acids. Right now, you know that just because I'm telling you that. Like, you wouldn't be able to recognize that. So if H2S was an acid, by definition, the acid is the loser, the base is going to be the gainer. So the H2S is going to go from H2S to H1S, and it's going to lose a charge, -1. And the H2O is going to go to H3O plus. This is the acid, this is the base. The acid turns into the conjugate base because cheerleading hands in reverse reaction. The base turns into conjugate acid reverse reaction. Okay. Ka is the same thing as Kc, is the same thing as Kp, is the same thing as Ksp. A for acid though. Products over reactants, coefficients become exponents, and pure solids and pure liquids do not go in. So this water does not go in. Water never goes in. It's a pure liquid. Okay? With your bad, buddy, go ahead and do B, C, and O. Cn minus by definition, bases are gainers. So it's going to go from Cn minus to HCN neutral, it gained a +1. H2O goes to H1O, which we call hydroxide. This is the base. Water this time is the acid because it could be either. The base turns into the conjugate acid because it'd be the reverse. And the acid turns into the conjugate base because it'd be the reverse. Our K is going to be B for base. But all K's are the same thing. We always take our products over our reactants, our coefficients become exponents, and pure solids and the pure liquids, so water, does not go in. Okay? So go ahead and do B, C, and D with your bottle buddy. There's another K, it's called KW. W stands for water, and that's actually super important. This is a really important constant. Water can react with water, because why not, right? They're going to collide, they'll have the right orientation of energy to activation. One of them, by definition, is going to be the acid is going to lose, the other one is going to gain. Let's pretend the left loses, so it goes from H2O to H1O, we call that hydroxide. The other one will be gaining, so it goes from H2O to H3O. But remember, pure liquids don't go in our equilibrium, so that this KW doesn't have a bottom, right? These would be eliminated, so it would just be products, no reactants, coefficients become exponents, okay? This is an important equation. KW is a constant. It's 1.0 times 10 to the negative 14. So that's a pretty left K. Negative 14th is like pretty less than 1. So that means, yeah, like most of the time it's just water molecules. It lies left. It's mostly over here. So like what you know about water is mostly true. There just are going to be some of these in there. Okay? So KW also does one more thing. Because of cheerleading hands, it's also going to equal Ka times Kb, which we don't need at this exact moment, but we will need sometimes. If we have our acid, oops, HA acid, right? By definition, it's the loser. The other one is the gainer. So our products over our reactants, but pure liquids and pure solids don't go in. So these won't have water on them. Because water is always going to be pure liquid. The higher the Ka, the stronger the acid. The higher the Ka, the brighter it's going to be. The more of those there's going to be, and that's what makes an acid. So the more H3O pluses there are, the stronger the acid. The only way to get more of these is to be a higher K because it shifts right. Okay? So you can rank acids just based on their Ks. Kb goes the same way, base plus acid, gainer, loser. KB is going to be our products over our reactants. Coefficients become exponents. Pure liquids and pure solids do not go in. Same thing though, the higher the KB, the stronger the base. Because righter. If I have a big K, that means it lies right. That means I got a lot of hydroxides. That makes space. Can you just quick talk about that? We're going to do some math. Ready, go. Math. Do you know where the button log is on your calculator? pH is on a logarithmic scale, so basically you're just pushing the log button. pH equals the negative log of that H3O plus concentration. So once we calculate that, we can just plug it into pH. There is something called a pOH. That's if we have a base. If we have a base, we can go negative log of the hydroxide ion concentration. They're cheerleading hands together. They have to add up to 14. If the pH is less than 7, we call that acidic. If the pH is greater than 7, we call that basic. If it equals 7, we call that neutral. And it's all just depending on the concentration, the molarity of the hydrogen ions. Okay, so let's just practice one. A sample of lemon juice has a hydrogen. Remember, this is a proton. All synonyms. It has a hydrogen concentration at 3.8 times 10 to the negative fourth. What is the pH? pH is the negative log of the hydrogen. Push your buttons. Less than 7. What if I asked you what the pOH was, though? We would take 14 minus that. 10.58. I'm not going to do any more sample counts because I think that's pretty basic. But you can keep working through them if you want. Your homework tonight for practice, the worksheet that I gave you, the front part 1 through 3 is just practice writing those equations again. So if you feel like, yeah, I know how to lose a game, I don't feel obligated to do them, but if you want more practice with that, the math though is the kind of important part. That starts at number 4. I would like you to at least do number 4 through 10. Which is just all the pH and concentration math, plugging them into there, 4 through 10. Tomorrow, though, your quiz is just on the KSP stuff. So tomorrow we're going to take a quiz. And then on Wednesday or Thursday, we go back to ice tables. Okay?